Hey everyone, this is my second time speaking in Israel, but this time is in front of a bit of a smaller audience, so hopefully I won't be as nervous. Um, so I'll try to present to you a bit about Go as a programming language. First, just the syntax overview, and then a bit about how it works and what were our problems and our experience with the language. But first, I'm going to start with why did Zemanta choose Go. Like first, when I joined Zemanta, it was mostly everything was in Python. There were some C++ for some critical code and some Java for Solar scorers. But mostly everything was in Python, and that worked pretty well for a number of years until we moved to to build our first real-time bidder. At that point, we noticed that if we are trying to scale the number of bid requests or number of requests that we are handling to the number that will bring enough money to the company, we'll have to buy so many servers that we'll just spend it on hardware. So we were choosing another language. And at that point, I think the only two candidates that we could think of were Java and Go. And my favorite at that point was Java, mostly because I was working with Hadoop and Kafka and Cassandra before in the company, and I knew that all the best libraries, all the best features are first written for Java. But we decided in the end that let's try with a language that doesn't have maybe so much legacy, that is a bit more fun and hip and so on, and it worked pretty well except for some problems with Hadoop and Cassandra and Kafka. Uh, so at the moment we still have just one team working in Go. Maybe like 1.5 team. That team owns two services. First, and by far the biggest one is our real-time bidder, and it's deployed on physical servers in multiple data centers. And the second service is our redirector, which we decided to deploy in App Engine, which was an interesting decision, and that also works quite well. So I think that for anyone just trying to wanting to experiment with Go, I think that App Engine is a really good idea for a home project or something like that. And it's even for our redirector, it works extremely well because redirector doesn't handle a lot of requests. And the most important part of it is that it's always available. And giving a Google to take care of your services worked pretty well for us. So now I'll just go over the 10 or something like that slides about how does Go actually look like. And this is the simplest possible program you can write. And this is a runnable program. You can compile it and run it. The Go program always starts with the main function. As you can see, you import, these are all the imports from the standard library. Otherwise, you can import with the full path, or you can import with a relative path next to this file, which was introduced later on, so it's not, we don't use it just for consistency's sake. And you probably see that the print line is written in with capital letter. That means that this function is exported from the format library. So all the things that are capitalized are exported, and everything that's not capitalized is just a private to the package. And the package is then basically in Go, every new folder is a package. And you always import the package. You cannot import a function or a struct from a package. You always import the package and call it with a package name. so you're never confused like what package is this coming from. Next two features are functions. They have very straightforward syntax. If multiple attributes have the same type, you can join them together, which I don't like. You can return multiple returns, never return more than 2, because then it just gets confusing. And the second return is usually used to return errors, because Go doesn't support exceptions. And you can define variables 2 ways. One is with the var prefix, and the second one is with the shorthand, which, whatever, like, why do you have 2 different ways of doing exactly the same thing? But yeah, exactly. So it's really hard to change it, but in your own code base, always decide like what would you like to do and use that. And this is how you can assign multiple returns. You can never assign it to a single variable and create a tuple or something like that. That doesn't work. You have to always assign it to 2 separate variables. I'll move to this side. So next are for loops. They're very standard. The only thing you'll notice that you don't need brackets around it. You can for loop and while loops don't exist, because for loops are basically doing everything. You can leave out the plus and it will be just a while loop, or you can just write this and it will always loop. So if you need to stop your program at some point for whatever reason, you can just write that. If statements support assignments in them, which can be useful from time to time, but not very often. Pointers. So coming from Python, mostly like, and for you coming from Java, pointers are the first thing that you have to kind of understand, because Go is value first for all the types. So if you have an integer and you pass it to the function, if you have a struct, pass it to the function, it will always copy it on the stack, which is a really nice feature, because if you want to, you can basically write a code that doesn't do any memory, any heap allocations. But if the structs are bigger, if you need to pass something by pointer, you do the same thing you do in C, and just use pointers. And sooner or later, like you learn that usually, like doing stuff with values can be tricky and easy to miss. Like you will forget that you got a value received in the function. You'll modify the field, and then you'll notice that nothing really changed after testing in the production. So sooner or later, you'll start using pointers more, and that's, I think, just a general good advice to just pass by reference everything that doesn't explicitly need to be passed by value. But you can always do that, and we do it quite often in the code that's very critical in the bidder, that needs to be fast, needs to not allocate stuff, so we don't put pressure on the garbage collector. So Go doesn't support classes, doesn't support inheritance, or anything that you would expect from a modern language. But so the only thing it supports are like a grouping of variables, and you can group them in a struct. But as a syntax sugar, you can put functions on the structs, and you create basically methods. And with that, you have something that looks very similar to classes, except they don't support inheritance. But like from the user standpoint, you call them with the dot. You will receive it as a first receiver always, and it works quite well. But in this example, you can see that even though this is a struct, you can just, if you don't take a pointer from it, this is just a value. It's not a reference to a struct. You can also use interfaces, and and Go has a very interesting feature that structs, like both structs and functions can fulfill the interface. It's not just the struct, and how the interfaces work in Go is that you don't, on the struct, you don't tell it like this struct has to be of type of this interface, but if the signature is the same, then it is of that interface. So if your function receives a reader, you can pass it any kind of struct that has a read method on it. Read method that returns, yeah. And like and you can also like create a new type out of variable and add functions to it, which allows you to basically extend types, and that's usually used for like serializers and stuff like that, but not often in normal code. Like next two slides are like slices and maps. These are, because Go also doesn't support generics, except for slices and maps, which are built-in types. And slices are just basically pointers with a length to array. So this is quite often a very very nice optimization trick that you can do. Is that in Go, if you want to have a subslice, you can point it to, like, you can tell you can create a subslice that points to this pointer and tell it that it has a length of 2, and without allocating a new array, you have basically a new slice that just has a subslice of the previous one, which is very good, but you also have to be very careful that you don't modify one without expecting the other one to be also modified. And if you want that, you have to explicitly copy the slice to the new one. So with that, you can optimize your code quite a bit, but it's also like it didn't happen. It happened more than once in our production code that something was modified that nobody understood. Like why? Until we went and saw that somebody just took the reference to the existing array and modified it. No. In Go, everything is mutable, except strings. Maps are just very normal. You can have everything as a key, or you can put pointer as a key, but then the exact pointer will be the key. Or very nice feature is that you can put a struct as a value as the key without defining the hash function. So the structs are very similar to data classes in Kotlin, that they just work how you would expect them to work. This is actually the right location of the Outbrain office. I checked it on Google Maps. So one nice feature that I like to use quite often, because the first programming language that I learned was JavaScript, are closures. They are nice sometimes for code optimization, because because they also don't do any allocations on the heap, and you can basically create functionality like you would with objects, but without actually having objects. And now for probably the most hated part of Go, which is error handling. And in Go, you don't have any special thing that would handle errors at all. Like, the only thing you do have is in the standard library, you have an error type, which is just a type that has a string method on it, and you can create it with a custom error message. So a lot of your code will look like that. You will call a function, expect an error as a return. You will check if the error is not nil, then you would do error handling. And the good thing about this is that every time you call a function, you see does this function has a capability of not succeeding. And every time you have to ask yourself, how am I going to handle that? You can never just say, okay, I'll just leave it to my global exception handler to return the 500 page. You have to handle it somehow. But what happens in reality that oftentimes, basically what you do, you will get an error and just return it to your caller, which then defeats the purpose somehow. And because this is the pattern that happens so often, like at the moment, I think that there is a concrete plan for Go to have default error handlers, which would will allow you to not handle errors every time if the only thing you want to do is to escalate them to your caller. But because errors are just basically an interface, you can define your own, and then you can add more stuff to it, like you can define your own exceptions. And like sooner or later, every company has their own error library, which is also not probably the desired thing to have. But yeah. And for one very interesting feature of Go is also like the defer, and defer is a keyword that triggers the execution of whatever comes after it after the function already exited. And it is triggered all the time, no matter if function returned with error, if it panicked, whatever happened, defer will always be called. And you can use that to release locks, like you would use finally in Java. You can use it to close your connections, to do any kind of housekeeping that you really, really want to do. You just don't want to use it too much in the most critical code because it is a bit slower than the normal function call. But I think in the newer version of Go, that's not even it's not even that much slower anymore. So now that we handled like the stuff that looks very normal to any developer, I'll talk a bit about gorutines. And gorutines are coroutines with a different name. They have basically the same functionality as coroutines in Kotlin, but they're like built into the language from the start. So you'll see like that all the code, all the standards libraries, everything is written with gorutines in mind, and the keyword to run the function in parallel is just to prefix the call with Go. If you do that, the program won't stop here. It will execute this function whenever it's convenient for the scheduler. And if the program exits before your goroutine won't finish, it will kill it. So you need to handle your own.
So in this case, work is not different because the program would exit before the.
So in this specific case, like I'm sure that a couple of words will be printed because this function also loops, and the scheduler will. Scheduler is like tries to be very fair, so I think it would print a couple of times, but it's not guarantees for it to print. And to do the communication between goroutines and your main thread, what is the most popular thing or most convenient thing to use are channels. And channels are just blocking queues. So if you use queues to communicate between threads, they behave very similarly. They can be unbuffered, which means that when you push stuff to the queue, your code will block until a reader comes and tries to take it out. Because there is no room for a message in the queue, you have to wait for a reader to take it out. And this is quite popular to use for synchronizing your code because you know that your program will block at that point. But you can also buffer them, so you can say that this channel has a room for 5 messages, and when it has 5 messages, all the writes to it will start blocking again. And so just like normal blocking queues. And you create them with the make channel and any kind of type you want. In this case, we start to some functions with subslices to the same array. They will calculate the sum of the subslice and return the result to the channel, and the X and Y will be read from the channel. And this is the syntax to read one item from the channel. You can also range over it. No.
So where is it blocked? The reading that is blocked?
Yes, so in our code, we will block here until the sum will be completed and will be written to the output. This is why we don't need to have any other blocking mechanism here, because whenever we receive the results, we know that this function completed. So next thing I'll talk about is a bit how does this work. And like I'll start with one of the most famous talks about Go by I think it was by Rob Pike, who like he spent an hour talking about why parallelism isn't exactly the same as concurrency, and in the end it concluded that it's almost the same. But it is, I think it still is a difference that is worth talking about to developers. And this is an example that he used, is that if you want to burn books, in this case, I think in the original example it was Visual Basic handbooks, was that you have a resource, you have like whatever you want to do with it, and then you have one worker that does the job. And then you want to parallelize it, you create two workers to do that. But if your bottleneck is the resource you are consuming, you didn't actually do much. So you have to think about like how will you make your job faster, even if in some cases you only have one CPU. And this is the most important thing when you're dealing with I/O, especially network I/O. Like even on machines with one core where you can do a calculation, just one calculation at a time, if you're writing a web scraper, you can handle thousands and thousands of requests to the server without blocking on your resource and just spending the CPU cycle doing the actual work. And Go does for you out of the box. So if you write a scraper on one CPU laptop, you can create thousands of gorutines, downloading pages and processing them, and it won't process just one at a time, because most of the CPU, like most of the time, will be spent on blocking on I/O anyway. So how does the Go schedule do that? And inside Go, you have three constructs. One is M is the machine. This is a physical CPU core. Then you have processors, and these are the OS threads. And on top of OS threads, you have gorutines. So one OS thread is always processing one goroutine at a time. This is this one. And then you also have a queue of other goroutines that are waiting to be handled on the OS thread. And what happens when, I think I have a slide for that, so I'll just skip to, yeah. What happens when a goroutine has any kind of I/O call, for example, a read from the disk? Go won't spend time on the main processing thread to handle your I/O. It will remove your goroutine to a separate thread and just take more work from the queue. And when the goroutines end the I/O wait, these goroutines will go back to the main queue. And this is because this is built into the language. You don't have to write your own yields and stuff like that you would need to do if you would use async I/O in other languages, because it's built into the language. It also does like work steering. If you have multiple cores and one queue becomes very large and the second CPU is basically free, it will go to the other CPU and steal the work from it. It doesn't have a global queue because it tries to do as much, like if one goroutine is running on the CPU1, it will try to run it there for as long as possible because the CPU caches there are warm and it will work much faster. But if there is another CPU that has no work, it will reallocate the goroutine to another CPU. But you can also tell a goroutine, I really, really want to stay here in this OS thread, and it will also allow you to do that, but that's only used like when you, I don't know, writing your own language on top of Go, probably. I don't see any other use cases. So I wrote some examples, and this is all the code except for I cut out the import that you need to create your own HTTP server. At the beginning, I wrote that max number of OS threads is 1, just for an example. By default, it's set to the number of not physical, but virtual cores in your machine. But I pin it to 1 here, so it's obvious what's happening. You create a new handler, and in this case, it's just a function that sleeps for 1 second and then returns the 200 response. And here I'm just blocking on listen and serve. And if I run this with Apache benchmark, I want to make 500 requests to this server with 100 concurrent workers. What happens is that this takes 5 seconds because the 1 second timeout in the Go program basically doesn't take any work for the CPU to do because it's just an I/O wait. You don't, and I'm doing all that with just one physical thread. You can push it a bit further with 1,000 concurrent requests, and then you can see that my laptop couldn't handle that with just one thread. I managed to do like 800 requests per second. And if you write, instead of your handler being just I/O wait, you can, if I have a busy loop here, things change a bit. I'm adding it to the global variable, otherwise the compiler knew that I'm not doing any work. So in this case, of course, if my concurrency is 1, it will take me like 8 seconds. If my concurrency is 5, it will still take me 8 seconds to process it because one core can just do one process at a time because it's a busy loop. So this is like the distinction between doing mostly I/O wait and some actual work.
If you were to connect with more than one process, these things would run in different threads?
Yes.
Will run in different threads?
Yes, if I would set here go max procs to 2 and my laptop has 2 cores underneath, it would look exactly like that. You would have like two physical threads, and goroutines will be scheduled on both of them.
Do you have to call goroutines? Do you have to write go something?
No, the code will look exactly the same. Just that the listen and serve will the reason why it would look exactly the same is because every new request that you receive is handled as a goroutine. Yeah, you don't have, your handler here is already running in the goroutine. So now a bit about the garbage collector, because Go is garbage collected language. And its garbage collector isn't like best in the world. I'm sure that Java's garbage collector is, especially the new ones. But it's pretty good, and the reason why it doesn't need to be the best is because it gives you, the Go as a language gives you a lot of tools So you don't have to create so much garbage that you create in Java, where everything is a reference by default, and it's almost impossible to avoid it. I know that there are databases that manage to do that by storing everything in a byte array, but that's not something that like a normal programmer would do. But what you can do is, in Go, is just use the language as is, and it won't create as much garbage as an equivalent Java process would. And what Go prioritized when they developed their own garbage collector was not the throughput of it, but the latency of it. And like in the newer versions, you basically have very, very tiny stop the words. So if you have enough CPU power, and enough memory, even with very large heaps, your program will almost never block. But it's like, to do that, it spends like 1/4 of the time to do garbage collection. And if you have enough cores, it will allocate garbage collection to one single core. So that core all it will do is do garbage collection. It won't interrupt other processes. And these are all the options that Go's garbage collector has to tune it. You can tell it when it runs out of memory, runs out of heap, what is the size of the new heap that it creates. So you don't have all that problems with like first choosing your garbage collection and then tuning all the different parameters and running your code again to see if does it work any better. If the code is too slow, if you spend too much time on garbage collection, you just buy bigger servers, which is good and bad at the same time. So now a bit about our experiences. And this is the first thing that I think that Go is most famous for, that it's extremely easy to learn. Any developer can just use the Go documentation and write Go code. Because there is no huge ecosystem around it, there is in Java. There are no frameworks. There are frameworks, but they're usually like not very popular, and not very hard to learn. It has just one formatter that you cannot change, and all the code in the world that you will look at, it will be formatted in exactly the same way. And it has, because it's a new language, it doesn't have like a lot of tutorials that you start reading and then you're noticing that it's for a very old version and that things change in the meantime. So you have basically two official tutorials. One is the tour of Go, which is just a step-by-step example that you can run in the browser. And the second one is effective Go, which goes through all the interesting things, like how you would write a parser for web pages in a couple of lines of examples. But in Zemanta's experience, of course, it's almost impossible to hire Go developers. So you can just hire any kind of developers and tell them to take an afternoon to read the tour, and they will be able to read Go code. To actually write a proficient one, you will, of course, need a bit more time, especially things around pointers and interfaces and the slices and how they behave. But it's a really easy language to learn. It deploys to a single binary. It supports it has a very good support for cross compilation. So even if you're on a Mac, you can compile it for a Linux and Windows, and it will just work out of the box. All the dependencies in our code base are vendored inside the repository. So you have all the code in your repository, which is good and not good at the same time, whatever you prefer. I mean, in the end, they are also in the binary, but they're also in the repository itself. So when you source code, yeah. You have like dependency management tools that are quite new. that will do that for you. So you can have like just a YAML or JSON with the versions, the same you have in other languages. But what these tools do is that they just download the code and put it into a vendor folder in the project itself. So it's very similar to NPM for node modules in Node.js, but it also, it's very similar to that. And one of the best features is that the compiler is extremely fast. So even with millions of lines of code, it will compile in tens of seconds. Because the language is so simple and it has a very clear definition of what is public and what is internal. The compiler doesn't have a lot of job and a lot of tasks to do, and it also doesn't do a lot of optimization. It does it like in each version there is a new optimization that the compiler does, but one of the main requirements for the Go core team is that no optimization should slow down the compiler too much. So this is one of their key metrics, and they're sticking to it. The biggest slowdown was when they rewrote the Go compiler from C to Go with the automatic transpiler, and of course that there was a slowdown if you just do it one by one, line by line. So like I said in the beginning, the ecosystem is pretty complete. One of my favorite features of Go is that it has an extremely rich standard library, so you never wonder, like, what CSV parser am I supposed to use? What JSON parser am I supposed to use? You just use the one in the standard library. And it has, like, basically everything that you need for day-to-day stuff. And, like, almost all databases and even, like, stuff that I listed here, Kafka has a default client. But if you want to use like Kafka streams or like automatic cluster management and all that, then you're left on your own. And our biggest pain point was probably Hadoop. So we have our own wrapper around Hadoop streaming, so we are able to write Go code for running Hadoop jobs. And for machine learning, we have like all of our CTR predictors and everything are handwritten, which has its benefits, but it also has its problems. I'm not saying that there are no machine learning libraries for Go, but they're not as good as Java or Python ones. And the next thing that is good and bad in Go is that because it's so simple, it doesn't allow you to be smart when you write your code. Like if you want to filter a list, you write a for loop, you add an if statement, you create a new list, and you append the items to the new list. And that's the only thing you basically can do because it doesn't provide you any other tools to do that. So every time you will need to, you see the code that is filtering the list, it looks exactly the same. And so you as a writer can get a bit of frustrated because you have to write it all over again instead of just calling a filter and then passing the lambda. But you, as a reader, know exactly what is happening in any part of the code base. And I think this is my last slide for our experience, is the optimizing Go code. Like in one of really, really nice features is the Go's profiler. You don't have to enable it explicitly. All the Go programs will do memory, will collect memory statistics, will do CPU sampling all the time. So when you connect to it, you don't slow your process down, and you don't have a problem of your profiles not being the representation of the actual programs because you're affecting them by profiling them. And you get a web UI where you can just click through the memory profile and dig down to the assembly code if you want to see what is the actual thing that is doing allocations or that is taking the CPU cycles. And the best thing to do to optimize your code is, in our experience, is just don't do memory allocations if you don't need them. And I think this is the same for basically all the like low latency, high throughput software. You can you can reuse buffers, reuse slices. You can use memory pools, which are basically just reference counting pools that you manually handle. They're not very nice to use, and they are bug prone. But if you're in your most critical code, this is what you do to make it work much faster. And one of the most important things in our bidder is that we are very, very careful about what we are putting into our hot path between the bid request and bid response. We are doing ton and ton of stuff offline, like generating features for predictor offline and just using them on bid requests. We are like preparing the trees of all the campaigns in memory and just using that in the hot path and just trying to make the path that is going from the request to the response as short as possible. Because then you can, on that path, you can use all kinds of tricks that are not as nice to write and read because it's not a lot of code that does that. And code generation for we are using it just for that. It's very much faster. If you cannot avoid using JSONs, you can just compile the JSON parser that is 10 times faster than the one in the standard library. So sometimes you have to go outside of the standard library. And this is a GIF about how the profiler looks like. I think this is for memory allocations. So the next thing is my experience in transition to from Go to JVM languages, and in my case that were Java and Kotlin. And the first thing that I noticed was the learning curve. Like, because it's a huge ecosystem with a lot of good and bad legacy. Like, there a lot of things are very, very good in for example, Spring. But Spring is a thing that you have to read a book about to understand. Like when I first opened OEM project, the only thing I saw there was just a lot of folders. Like, there was nothing that indicated to me where are all the entry points and where is the request coming in, where are all the jobs run, like how. And in Go, you open the things that you compile and you see, this is my main function, this is what it does. Which is, when the project grows, is not very large because your initializer will also grow and it will be hard to read, but at least like everyone can go to Kubernetes and open the kubernetes.go and will know how it starts up. Hibernate is also like a thing that I still don't understand. And Maven is something that for all Java developers is not all, because you have other tools too, but for all of you, probably something that you just type all the modifiers from your memory, but from someone that never used it before is just impossible to use because the documentation is not good. The defaults are strange, and it's just a pain to use. But because it's an ecosystem, it's also all the things are also like thought out how you are supposed to do them. In Go, that's not the case. Like when we needed to do the dependency injection, we had to like think what are the best approaches to do that, and we chose one, and we didn't like it, and then now we have like 2 different ways of doing that. If you use like an enterprise framework, this will be handled for you. It might not be nice, but it will be consistent, which is the most important thing usually in the code base. And the next point is that the bootcamp, the new bootcamp came just in the right moment for us to use, and it was very, very good. And yeah, like this is my point about Kotlin. I like it quite a lot. I think that I'll use it even for projects for outside of OEM, especially like for scripts and stuff like that, because it's really a nice language to use and write. You can write a lot of one-liners that do a lot of stuff very quickly. You don't have to type out all your code like you have to do in Go, but you can also, because of that, it gives you like the feeling from time to time that you have to solve your problems this way. If you want to, like, if you have to aggregate list to a class, maybe I'll just use the fold and then do the lambda and map and all that, and it will all look nice in one line. But when anyone else that's not you, or even you 5 minutes after you wrote it, will try to read that, you'll have a hard time. Okay, that was it. So if you have any questions, I'm still here for like, we have like 15 minutes left, I think. I forgot to add a question slide. So.
Can you talk more about the benchmark testing? Like in your, so I think that's a feature that like a lot of people think it's abstract. You don't know what that means.
Yeah.
Okay. And I think that's like a huge thing because you see exactly, okay, I did the code change, compare to what previous connected, this connected.
Yeah, thank you so much. I think this is the biggest thing that I missed in this presentation. I wrote it just as a one-liner here, is that first thing when you try to optimize your code, you start with a profiler, because you want to know what's happening in your code. And the next thing you do, you write a benchmark test for the piece of code that you're trying to optimize. Because the optimizations that you do without knowing what you achieve are usually useless. Because even if you think that you did something good, it's quite possible that you didn't achieve anything. So the first thing that you have to do is write a benchmark test. And benchmark tests are built into Go testing library. So you just write them as a normal unit test, with one difference is that you get in a number of how many iterations do you need to do of your code that you are benchmarking. And so you do preparation, like you prepare classes, you do a warm-up, then you say, okay, now I'm starting my benchmark, you do the n iterations, and then you return. And Go will tell you, okay, for one cycle of your benchmark, you did 5 memory allocations, you used 30 nanoseconds, and it will also export you, if you want to, a profiler of just that benchmark. So you can then go to your profiler and see, in my benchmark, all my allocations were in this line. And you can say, okay, maybe I just put this into a memory pool because I'm using it all the time, and I don't need it afterwards, after the function already returned. And Go standard library also has a lot of benchmarks. So every time the new version comes out, they will publish the difference between the old and the new one, so you know for each item in the standard library, like did it get faster or slower, or what's changed, which is always a nice thing when your code gets faster without you doing anything. So yeah. Any other questions? So the question is about the community. So in my opinion, is now that the community is pretty big. I think the biggest problem that we have is that it focuses on different things than Java community. So like in Go, if you look at what are the best Go libraries out there, they're usually like very fast HTTP servers. There are like very fast JSON parsers and stuff like that, like very fast routers. And because Go is usually used for services, for edge services, for things that are processing a lot of requests, it's not very often used for data processing. And so what we are missing mostly are the big data libraries and tools. Because all the existing companies that are adopting Go still probably have a huge Hadoop cluster, and they don't see a need to migrate to new things for that because it's very critical. It's much easier to just create a new service that's sitting somewhere in a new language.
Do you consider rewrite only for Go and some leveraging Go feature for that, or not using it for
So the question was if I would rewrite OEN in Go, and the answer is no. Like I would, in general, avoid rewriting any project into at all if it's not altogether a complete disaster, or if the product changed so much that there is no other way. And I think that even if I would write it from the ground up, I'm not sure what language would I use. Like at Zemanta, when we wrote our setting synchronizer that synchronizes settings from Zemanta 1 to Bidder and to Amplify and to other external services, we wrote it in Python, which is the decision we regretted later. But at that time, like there is like, but I'm not sure if we would choose Go to do that. Maybe. I think that that Kotlin is a very nice, sits very nicely in between, like covers like this space really nicely, and I don't mind it at all for OEM project. But like now that we are hitting some performance issues, it is sometimes quite annoying that you're not able to just say, I don't need this as a reference, just keep it as a value and don't pollute my heap with it. Okay. Thank you.